All right. Why don't I, as folks finish signing up, let me bite off a couple of the smaller questions here. So one of the questions was, what is a content delivery network, or CDN? So CDN really is a generic term describing servers whose purpose in life is to deliver content, which simply means they are web servers that have hard drives or some other form of storage that people put files on, generally static files. And by static, I mean unchanging. You write them once, you upload them, and it's an image, it's static text. It's not a dynamic, interactive website necessarily. And the CDN's purpose in life is just to spit out those files when requested to browsers and do it ideally in a very efficient way, possibly by using a lot more RAM than might be typical, just so that it can respond very quickly to requests. And Akamai initially built its business on this kind of idea. Amazon and Microsoft and Google all have similar services as well. So there's not all that much that's fundamentally different from servers with which you're familiar, but they tend to be global as well. So using various DNS tricks or load balancing tricks, do they make it easy to distribute your data globally, because there will be different servers in different countries or continents for different users. So we, for instance, distribute a lot of our course videos via Amazon CDN so that we can push it out without having thousands of people come to harvard.edu servers to try to download the same. And indeed, when we tried that latter approach years ago, the servers buckled under the load for some of the largest of files. Griff?
I was just going to say that at edX we try and do a lot of international information, and many of the locations that we try to have our courses access are blocked.
Yeah.
Especially in China and a few other places. So having a CDN or having a local hosting provider allows us to circumvent Great Firewall, China, and other things like that. Otherwise, videos will be blocked. I'm sure you've had this experience, or it'll be like massive latency.
Yeah, absolutely. So that's a good workaround for when popular consumer services like YouTube are indeed blocked. And even Netflix you can think of as a CDN of some sort. And in fact, to address some of that same issue for cost reasons, though, or for bandwidth reasons, they have, at least they used to have, a Netflix appliance that you could actually have ISPs install locally, so that if Comcast, for instance, was getting tired of having the same movie files, for instance, downloaded over their network from some other network, or if this is just burdening their network, they could actually cache the files locally, which is some form of CDN as well, so that users end up talking to that local cache server instead. The security of the Internet of Things. So just to clarify, what does the world mean when they say Internet of Things these days, IoT? It's kind of the buzzword du jour. Felicia? Yeah. Yeah, for some reason, my go-tos are always the things in the kitchen, too. Yeah, it's like putting everything on the internet. Nest thermostats, which I do have and which I'm a fan of, and other such devices like your refrigerator, if it's got a little touch screen, and the smoke alarms, which that did not go over well for Nest initially. Bad to release a product where safety is at stake when you have buggy software in it, if you Google up on that fiasco. But Internet of Things really just describes putting more things on the internet. And I think the question earlier was, can we speak to the security of it? I dare say I'm fairly pessimistic when it comes to this. I think we humans have made the exact same mistakes in the world of phones that we did years ago with PCs and Macs and desktop computers more generally, where we don't write very good software. And there's innumerable articles out there about various devices that are still shipping with default passwords of admin or password or no password, or some engineer has hard-coded something into like a home router and no one thought to disable that. And the sort of list goes on and on. So I dare say the Internet of Things won't be very good at security, because we humans haven't gotten all that much better at these kinds of issues. But it's interesting to consider the sort of new threats that are imposed. In fact, I remember it was a wonderful gift from a friend of mine when I had first gotten a couple of cats years ago. He kindly gifted to me this cat feeder that itself was like electronic. So if you travel, it can feed the cats automatically. And it had this audit feature whereby it had a little webcam built in, so you could actually see the food bowl, which is good for reassurance that the thing's not jammed, or to call a neighbor if the cats aren't actually getting fed. So it's a compelling use case for a camera. But the way it worked was, in order to see your live webcam feed from your cat food feeder, it was going through some server abroad. So you would go to something randomwebsite.com in whatever country, and that's how you would watch your live feed. So it wasn't that you were connecting to your home's IP address and you weren't running a web server in your home Rather, the camera was transmitting this data, similar in spirit to Dropbox, to some central server. And if you want to see those bits, you log into that central server as well, which means any creepy employee of this company has like literally a window into my home. So it creeped me out, and I couldn't do it. So I returned it. It's gotten me thinking ever since then about home security cameras, things that are on the web. Like if you are visiting your own home security cameras data feed on someone else's website, they too have access to it. And so these are particularly concerning things. Avi?
Wasn't the only thing we kept?
What's that?
Was the only thing?
No, because it had a wide enough field of vision where it would capture the ball, but also, you know, anything over there. And, you know, maybe just at waist height or whatnot, but it was just like unnecessary information for me to just be handing over to someone 24/7, I felt.
Yeah, that's my fear with smart TVs with cameras in it too. Smart TV, I mean, they're all just responsible for TV. Camera and everything else is kind of thrown in.
Yeah, no, I'll admit to being paranoid enough where I do not connect my smart TVs to like the internet because it creeps me out that one, many of them have cameras now for what I think are stupid features like waving your hand to change the channel or the volume or whatever, which can't possibly work reliably in 2016. So there's that. Samsung took a lot of heat a year or two ago now for their smart TVs in whose privacy policy it was disclosed. It was something along the lines of, it was brilliant wording. It was like, we recommend that you not have personal conversations within view of this TV. It was something like that, where they were disclosing it, albeit not on the box. It was in like the tiny little printed brochure. Because for the TV to be able to respond to this, or to be able to respond to your voice a la Hey Siri, it's got to be listening all the time. Look, Alexa from Amazon creeps me out for the same reason, because if it's constantly listening, which is billed as a feature, well, who knows what else it's listening to? And the fact that, you know, watching TV in bed or on the sofa, like I don't want this like constantly projecting whatever it sees onto the internet, and even the voice stuff too. So I try to disable all of that. And even here, I mean, we humans are bad. Just 2 years ago, there was this wonderful article about Samsung's smart TVs, which were being so incredibly dumb. They were transmitting their data on TCP port 443, which recall is the secure port for HTTPS, but they weren't encrypting the data on that port. So it was though some dummy engineer sort of knew that, oh, you're supposed to run secure traffic through port 443, but didn't realize you also have to enable encryption. Like it's not enough just to use that number on your virtual envelopes. And so here too, all of the data, and some researchers somewhere noticed this, like all of the voice commands or whatever it was were leaving the TV unencrypted so that any creepy person in your Wi-Fi network or in your, with physical access to your network could see what's coming out of your TV. So yeah, so Internet of Things is frightening. It just means putting more bad, buggy software and hardware in our physical presence. So beware and be mindful of these things, because I do think we can exercise some judgment. So if you think that baby monitor is a great idea to put over your child all the time, realize that those bits might be getting transmitted to some creepy company or some third party, and maybe that's not really a threat, because who's really going to care? But if the server is compromised, and now you do have someone else having eyes into your home, like this is going to become all the more common.
On Google Photos, I tried it. You can recognize my face from a mouse group of people.
Yeah.
So suppose it gets on the internet, right? There will be all kinds of pictures I'm not aware about because someone else made a picture.
Yeah.
Guess what? If I'm in a train and you have troubles with someone, it just makes a picture of your face, figures out who you are, in a nutshell.
Yeah.
Right? So if that gets on the internet, it gets publicly available, which isn't yet, but when it gets publicly,
Yeah, this is kind of the next frontier of.
You get all scary things because what those people do, they will sit at an abortion clinic and make some pictures of women who get out there, figure out identity, send a picture, say, hey.
Yeah. And this one, I dare say, is inevitable, just because all it takes, per our discussion yesterday, for one association of you with that history to be made before you can reconstruct the entirety of your history, right? If you've been photographing someone for years, but you've never figured out who they are, all it takes is for one time for someone to capture a photo associated with their identity, and now we can look back in history and be like, oh, we have these other thousands of photos of this individual.
Because what I always do when I hire someone, I always check the name on the internet, right?
Yeah, now you can check their face.
To a beach, when Top is there, and someone else made a picture, right? She didn't make the picture, someone else made a picture.
Yeah. And it doesn't help that most of us are proactively tagging ourselves on Facebook and other social media, so we are creating this database as we speak. Yeah, no, this one I unfortunately think a little bit pessimistically is inevitable. We're not going to be able to avoid it, especially when the cameras are being put. I mean, the UK has had this for years, but it's really just for recording. Now, facial recognition takes it to a whole new level. I'm already impressed, too, how good Facebook's got getting it, like tagging friends when even their head is slightly askew and it's not a great shot. I mean, it's getting better and better, so beware. Some of this stuff, I think, is in our future. Speaking of, how do you write stuff like this? So programming. So what we thought we'd do here is really just give everyone a taste of what programming is, albeit in a playful context using a graphical program that we use in our undergraduate class called Scratch. This is a graphical environment that you might have gleaned some images of as you registered for an account. Even though it's playful and technically meant for ages 12 and up, it is actually wonderfully representative of a typical programming language, a certain type of programming language called a procedural or an imperative programming language. Insofar, and as such, it's very similar in spirit to Java, JavaScript, Python, PHP, Ruby, C++, C#, any number of languages that you might have heard of, but it does it in a much more playful context. But it'll allow us to talk about examples of code without actually seeing more arcane code. For instance, just to give you a sense of context, if I wanted to write a program in a language called C, I would open up a text editor like this, and this happens to be a program called Vim, but it could just as soon be a program like TextEdit or Notepad. All you need is a text editor. And I'm going to type some magical incantation like this in this language called C. Int main void, and then I'm going to have some curly braces, and now a printf, hello world. And now I'm going to say, let's say, return 0. OK, so some of you might recognize symbols and syntax like this. But for those who don't, you can perhaps guess what this does, even if you kind of just ignore anything you don't understand. Take a guess as to what this program does if you've never programmed before. Take a guess. Yeah, prints hello world. I don't really know what return means or int main void or include standard io.h, but printf, albeit, print sounds familiar. Hello world looks like a sentence. So let's see what happens. Now this is a file called hello.c. And to run it, I would normally on my Mac or PC double click it. But this is a text-based environment, so I can't do that. I actually have to run it. But to run it, I first have to make it or build it with a compiler. So GCC, GNU Compiler Collection, or GNU C Compiler, is a program that has just turned hello.c into the equivalent zeros and ones that my Intel CPU will understand. And if I run this with this magical incantation, a.out is just the silly default name for my program. Enter, indeed, as was posited, print hello world. Sorry, so not all that interesting. Let's rewrite this in Java. So hello.java. Class hello, public static void main string args. Java's even stupider when it comes to like starting the writing a program. System.out.println hello world. OK, that is the equivalent program in a language called Java. It's a little different, but you can kind of glean some similarities. There's still curly braces. There's the same string, hello world. There's the word printf, although I could actually do this with print line would be a little more common in Java. Class is a new word. It hints at features called object-oriented programming, which Java offers, as do some other languages. But this is generally what a text-based language does. Thankfully, there's even simpler languages. So if I want to write a program in a language called PHP, I can simply do print hello world. And this one is now done in PHP. And you can do this in Python, Ruby, anyhow. So there's many different languages in the world of programming, much like there are many different spoken languages. And much like we could communicate in English or Spanish or Japanese or any number of other spoken languages, so can you write programs that at the end of the day do the same thing. These programs all print hello world, but you express them. You write those programs in different ways. So why? Right? I can kind of understand that there's like thousands or millions of years of history over which languages evolved independently in different cultures and kind of mutated over time. But we humans also invented pretty recently programming languages. Relatively speaking, why is there not one programming language with which you write software? Competition in what sense? Okay, so people might have wanted to make money off of this, so make a better language than someone else. What might it mean to be a better language or a competitor language? Yeah, Inessa.
Different languages are optimized for different things. So
Yeah.
whether you're trying to, use data in a particular way or visualize things in a particular way or query information. I just see different or have different responsive design, different languages are best applied in specific use cases
Yeah.
or intermingled in their application.
Which is similar in spirit to the idea of competition. People have decided over time, hey, I can do this better, or we can do this better. And better might mean different things. It might mean that your software, at the end of the day, runs faster than someone else's. It might mean that your software is easier to write than other languages. And it might not be competition in a business sense. A lot of languages have been developed by academics because we think we can do a better job at improving upon previous languages. And there are different approaches to languages, one of which would be called an interpreter versus a compiler. And what I just did a moment ago was to write a program in C, my very first program, and I ran it through a compiler, that thing called GCC. And what that means in real terms is that you write a program that looks like this in English-like syntax. It was definitely cryptic, but Katie was able to glean what it did, print hello world. You run it through a compiler, and then at a little bit of an oversimplification, what comes out of that is a whole bunch of zeros and ones that the Intel CPU understands. And the compiler is specific to the CPU, so that if you have, back in the day, a Mac or a PC or some other kind of device, the compiler would spit out zeros and ones that the Mac understands or the PC understands or the Linux computer understands. It's also tied in part to the operating system, not just the underlying CPU. Most consumer computers these days have Intel CPUs, so they're using the same underlying hardware, but the operating system is certainly different across different types of computers, Macs, PCs, and the like. And so this is generally what happens here. And what does it mean for Intel to be inside? Well, among the things an Intel CPU or any CPU does is it has a certain set of instructions that it understands. And I proposed yesterday, they're pretty basic instructions like addition, subtraction, multiplication, move something from here over here in memory, load something from here to here in memory. Very simple operations. And in the interest of abstraction, let me just stipulate, you can get from addition and subtraction and multiplication all the way up to Photoshop and YouTube and playing videos and the like. There's a layering there. But a compiler is necessary to go from something that's pretty human readable, if cryptic looking, to the uninitiated, to those zeros and ones. An interpreted language, by contrast, rather skips this step. And actually, I didn't quite leave enough space on the board here, so let's CPU. From there to there. An interpreted language might look the same, or rather, in a language that you're planning to interpret, you run it through an interpreter. And at the risk of oversimplifying here too, let me just say that it essentially gets run directly on the CPU. There's some stuff happening. Really, what the interpreter is doing is reading your code, top to bottom, left to right. And anytime it sees an instruction it recognizes, it inside of it has zeros and ones that the CPU understands. So the interpreter is what's running on the CPU, and it's interpreting your program line by line. By contrast, when you compile a program with a compiler, it's your zeros and ones that are running on the CPU. And that's a reasonable distinction. So historically, languages like C and C++, older languages, were compiled. And a lot of more modern languages tend to be interpreted. Technically, you can compile or interpret any type of language. It depends on if the software exists. But they correlate with certain historical traditions. So C and C++ have tended to be compiled languages. More modern languages like Python and Ruby and PHP have been interpreted. Java is kind of a weird middleman whereby you do compile it, but you compile it not into zeros and ones per se, but into something called bytecodes. And bytecodes are instructions that the Java virtual machine understands. So among Sun Microsystem's contributions to the world years ago when they invented Java is instead of assuming an Intel CPU, they essentially created their own CPU in software so that their Java code could run on Macs, on PCs, on Linux computers. But you had to have the Java virtual machine software, the Java runtime environment running on your computer. But that's still used today in different contexts. But this is a reasonable type of categorization. Interpreted and compiling your software. All right, so let's just do a quick laundry list of languages, if only to get it out there so as to distill or to dispel any confusion as to what languages are. So C, C++, C#. Take it from there. What else have we heard of? Go, yep. Go, Java. I heard JavaScript, I think. Fun fact, not at all related to one another. JavaScript came after, and the marketing people decided that, ooh, Java's so trendy, why don't we call our language JavaScript? Essentially dupe people into thinking they're related and get this one popular too. Turns out it became popular, but has no relation to Java. React would be a framework, not a language per se. Python. Ruby. I am actually amazed. We are actually doing these alphabetically accidentally. OK. Amazing. All right, Python. I heard Ruby. OK, I can only take languages starting with S or later. SQL. We'll talk more about that later. Perl. Oh, damn it. You broke my system. Perl. No. OK, so PHP. Django is a framework. So we'll talk about that later, not a language. But we'll distinguish what that means later. What's that? VBA? Yeah, Visual Basic. Yeah, so VB or VB script. .NET isn't a language per se. It's a collection of stuff that you would usually use like Visual Basic or C# with. So I put that into the framework category. Other languages come to mind? Swift is a new one from Apple, designed to make iPhone programming and Mac programming easier. Objective-C is the earlier language that they used for many years on Macs and iPhones. Julia? Oh, I don't know that one. This? OK. Nice. Others? Yeah, so Basic, Pascal, COBOL. I used to capitalize all languages. Fortran. It's a lot. It's kind of overwhelming. Right? And many programmers will know many languages. I dare say far more than a typical human would understand spoken or written languages. So why is that? Well, I think Anissa made the claim earlier that different languages are better for certain things. And that's indeed the case. And most anything we discuss today will be a sweeping generalization because there's a lot of religiousness in the technical world where people will bring to the table their own biases or preferences or experiences. And this, too, is an important thing to realize, especially when hiring technical folks or discussing things with engineers. They're going to bring their own solutions to the table. And it's perfectly acceptable if someone's recommending something just because they know it well, they've used it well, they know the ins and outs, because that alone can be a positive and save cost and so forth. But it can also be a downside if someone's knowledge or expertise is dated, if they're using the wrong tools for the job. For instance, like back in the day, I first learned web programming in a language called Perl, and this was 20 or so years ago. Like no one really uses Perl for web programming anymore. And you can. It certainly still works, and they've continued to modernize it and add features, but just no one really does it. And so it would be a strange choice, but not an indefensible one. Using C is possible for making websites. That would be very, very strange these days and harder to justify because you have to write so much more code in a language like C to get real work done because it just wasn't designed for that. By contrast, PHP was designed for the web, and it was actually designed fairly sloppily initially, but it made web programming so easy. And one of the reasons it's been so accessible is because it's been so deliberately intertwined with web development. More recently has Python and Ruby gotten popular for web development, but neither of them were designed for the web per se in quite the same way as PHP has. So per our upcoming chat later, there have been a lot of libraries or frameworks that have emerged. People have written code to make your life easier if you want to use Python or Ruby for web programming. Rails, for instance. Ruby on Rails is a popular expression, and it describes a framework that allows you to use Ruby for web programming. So the short answer is it depends. And if I had to make a bold claim for web programming these days, which will be our focus later this afternoon, JavaScript is prerequisite, because thank God there's only like one language that you can really use on all browsers client side, more on that later, but running inside of the confines of a web browser. So you pretty much only get JavaScript there. But also super popular on the back end, so to speak, would be Python, Ruby, PHP, C# in the Windows world, and Java, I would say. And that's changing, and even that is just kind of current trends. Go is increasingly popular, and other languages still could be used, and there's some not even on the list here. So these are really just tendencies.
Is HTML5 in that list?
No, so per yesterday, I would emphasize that HTML is a markup language. It's only about aesthetics and structuring of data. It doesn't have the ability, as we'll soon see, to express yourself logically. And there's a couple little exceptions to that in CSS. But no, it's not a programming language. You could not write, well, you could make a web page that says hello world. You could not write a program that runs on the CPU of a computer that says hello world with HTML.
A lot of places are saying they want it from Java, they want to do HTML5. Java or Flash?
That would be well, it's slightly apples and oranges. I know what they mean. Java is a horrible language for making web pages because it never caught on. The web, it was designed as a wonderful idea. You could write your software in Java. You could then embed what's called a Java applet inside of a web browser. The problem is that browsers never really supported this very well. Apple has had a little fit with Oracle, and it doesn't make it easy to even use Java on Macs these days. And it was always damn slow to load a so-called Java applet in the web browser. It wasn't necessarily as accessible as native browser support was. So Java applets are dead so far as the web are concerned. It has been the case for some time. So if there was legacy software written in Java, not a good thing for the web anyway. Using HTML5 technically refers only to the language you talked about yesterday, but it's also arguably an umbrella term for HTML5 and CSS and JavaScript, and that would make sense. So they're kind of oversimplifying when they say that, but that would be the casual way of saying it. Good question. Yeah? Yeah, Scala too. Also very popular, especially with data-driven applications. But in short, there's not necessarily one right answer, but there probably are some wrong answers. And the way to glean what's appropriate here, especially if you're vetting a proposal from some engineers or you're trying to decide whom to hire, is frankly, especially if you're relatively non-technical, is just ask the advice of someone technical you know to vet their resume, or maybe Google around as to the technologies the person or persons are proposing to bring to bear on the solution, just to get a sense of whether or not they're making good decisions. And we'll see this afternoon there's any number of other lower level design decisions independent of language that can also kind of hint at the quality of someone's thought process or experience as well. Fortunately, in the phone world, so let me actually clarify a couple of these. So let me propose that back end, front end, back end, and then M for mobile, and also Java would be mobile. So thankfully, in the world of phone development, of web mobile applications, you pretty much only have Swift. You only have Swift and Objective-C on iPhones. Or in the world of Android, you have Java. And those are by far the biggest phone providers. So those are kind of the only two scenarios to consider today. However, there's a middle ground. You can implement mobile applications using HTML5 and JavaScript and CSS. And in fact, a common strategy initially, especially for startups who don't have the money or the time or the expertise to develop not only an iPhone application and also an Android application and maybe Windows Phone or a couple of other things, is instead not to write any code in Java or Objective-C or Swift, but instead implement essentially a mobile-friendly website and then use third-party software that gives you a tiny bit of Objective-C code or Swift code or Java code, but then you follow their instructions and you embed your web-based application inside of a tiny bit of Objective-C, Swift, or Java code that someone else wrote. You run a special command that creates for you a native Mac OS, iPhone or Android application that you can upload to the App Store or the Google Play Store, and so users can actually download it or even pay for it in the store. But really, that's just giving you a big rectangular region in your app, the contents of which are actually just a web page. So the upside of this is you don't have to know any of these languages. You can do all the stuff we did yesterday, plus a bit more when we talk about JavaScript later today. And you can build it once, literally, and it'll work on all different platforms. So the upside of that is obvious insofar as you now need no expertise here. You also don't need to hire twice as many people to develop twice as many apps for iPhone and for iPhone and Android. But what's the downside, perhaps? Why doesn't everyone do this? Why are these M's even on the list?
Can't do much cool stuff.
Yeah, you can't quite do as much cool stuff. So for instance, web-based applications tend not to have as much access to the hardware itself. So if a web-based application wants to know your location for like a map-based tool, GPS-based tool, the user is going to be forcibly prompted, hey, this web page wants to know your location. Is that OK? You might not want to allow that experience. That's not a great UX or user experience. Minorly annoying. You might not have physical access at all to the camera. Like a web page or a web-based application can't necessarily turn on your camera. It'd be a little creepy if you visit a website and suddenly your camera turns on. So there's those kinds of defense mechanisms in place. The frameworks I alluded to earlier that allow you to wrap your program in someone else's code and create the illusion of a native application sometimes do give you access to the hardware, but not all of it. And it tends to be a little slower to run web-based applications. Facebook's mobile app initially was web-based, and if you use it at all, you might have forgotten how slow their web app or their phone app originally was. And that was because it was really just a web page. So when you clicked a link, it was like reloading more content. It wasn't native. So native applications, so to speak, written in these three languages just tend to feel zippier. They tend to feel faster, more performant, and they're much, much, much better for games and such using native. Native means written in one of these languages. And web app would be written in HTML, JavaScript, and CSS. Good question. Yeah. No, just.
No, I have a question.
Okay.
Is the big picture like tens of languages, hundreds of languages, thousands of languages? What's the like bigger?
Define big picture.
Landscape. What's the bigger?
You mean the total landscape?
Yeah, total landscape. Or like
Oh.
right here are some of the more common ones.
Yeah, it's bigger. Hundreds. I mean, there's probably some that are not on the Wikipedia page I'm about to pull up to try to overwhelm you. Oh, here it is. List of programming languages. So those are the A's, the B's, and there is one called B, which came before C. Here's the D's. So here's the landscape, if I can punt to a Wikipedia answer. But most of these are fairly specialized, outdated, silly, the pizza language. I don't even know what that one is. R is popular. We could have tossed that on the board. That's popular for data analysis stuff these days. And there's some silly things. Unreal Script, presumably for a gaming engine. Very few Z's and Y's. So that's where you want to go if you want to come up with a new name, perhaps. So that's more complete landscape. And I'm guessing there's some missing from there still. All right, so you have all of these ingredients, all of these languages. What does it mean to be a programming language? What are some of the basic constructs? Well, at the risk of being, let's see, how might we implement this? Yesterday's example of the phone book. Let's write that program. So recall that I was searching for Mike Smith, and I wanted to somehow find Mike Smith in the phone book. Let's see if we can't translate the human intuition we had for our third algorithm, the fastest algorithm, into something code-like. And indeed, a language not on the board, because it doesn't exist, is called pseudocode. And this is just arbitrary English-like syntax. There's no standard for it. But it just should be roughly intuitive and human-readable to anyone. It's no special syntax for this, no curly braces or any of that. So what might have the first step been? Pick up phone book. What's the second step from yesterday? Looking for Mike Smith. Flip pages? OK, so let me say, this feels way too vague and abstract. So let's undo. And that would seem to induce an infinite loop, if you will. Flip pages, what does that mean? I kind of do that endlessly. We have to be more precise now. Half pages. So OK, so how about open, let me just say, to middle of phone book. And that feels reasonably precise. We could then really be nitpicking and be like, what do you mean open the phone book? But open to the middle of the phone book, then what? OK, so look at pages, decide if name to left or right. Feels like a reasonable way of expressing it. And now I have kind of a decision point. These are all instructions or statements, or I might call them functions. These are actions. Now I have to think. What's the question I need to ask myself? Yeah, so is Mike Smith on page? If yes, then call Mike, for instance. Else, if no, and actually, let me try to simplify this because I'm being unnecessarily verbose. Let me change this to, if Mike is on page, call Mike. Else if Mike is to left, so now we can kind of clean things up into cases, if you will, or forks in the road. If Mike is to the left, what do I want to do? Go left. OK, so how about we tear phone book in half. And now search left half for Mike. How do I search the left half for Mike? Well, what's kind of interesting is I already have an algorithm for search. And I could clean this up. There's different ways of expressing ourselves, but what I've just highlighted in blue is exactly the same algorithm that I need. So let's stipulate for today that when I say search left half for Mike, that is sufficient detail. And we can clarify this as follows. Back in the day, languages like BASIC, one of the earlier languages, used to number its lines. And so let me just go ahead and number these lines for discussion's sake. Whoops. That's a bug. Search per, how about tear, keep left half, go to step 2, to be specific. So that seems to induce the sort of cyclical behavior that we want. All right, what should step 9 be? Uh-huh. In half, keep right half. Good. 11, go to step 2. And is that it? End. So yep, we should probably add that. So end and actually you've kind of, this is a good example of, now I've created a problem. Thankfully in modern languages you don't number your lines, so you don't have to worry about this. But for the curious, or if you ever remember, the language BASIC years ago used to have this convention where your first line of code would be 10, your second would be 20, your next would be 30, your next would be 40. Why might that have been? Yeah, so when you screw up, you actually have 9 mistakes you can make before you have to start renumbering things. So that was one approach years ago. Yeah, we should probably have an end. How about we'll cheat, then end, just to cram it in there for now. But there's one case I'm not considering. There's a fork in the road I've not addressed. Yeah, Grace? Yeah, so else if Mike is to right, else if Mike is on page, call Mike. So I kind of need, and it's a little non-obvious based on how I've written it, how I weave this logic in. So I'm going to cut a little bit of a corner and say else if out of pages, give up or something. And I say I'm kind of cutting a page because like I can't tear, I should kind of have it up here, right? Because I can't tear the phone book in half if there's only one page left. But let's assume that the spirit of this is to capture all 4 cases, which we now have. Otherwise, there might have been undefined behavior. And indeed, if you've ever been running macOS or Windows software where like you suddenly see the stupid beach ball just spinning and spinning, or the program crashes, or it hangs, yesterday we proposed that if it's just hanging or slowing down, it might be because of virtual memory and swapping. But if it seems like it's not working correctly, not just slowly, it might be that someone didn't anticipate a situation. And programs will crash if they encounter, for instance, the equivalent of like an out-of-service branch and there's no code there to handle it. It might just crash because you haven't anticipated a scenario like that last one there. What if Mike's not in the phone book? So this is just pseudocode, and we could have written this in any number of ways, but it rather captures the spirit mechanically of what we wanted to do yesterday. So now let's transition to a sillier, but just as real environment for programming called Scratch as follows. I'm going to go here, and we'll give everyone a moment to play around in a bit, but let me give a couple of examples first. This is Scratch's programming environment, and there's 4 main areas. There's the stage up here, this big white rectangle where this cat named Scratch lives. There's down here the sprites palette, so you can actually have multiple characters. You can change Scratch to a cat or dog, rather, or whatever else. There's this palette of menu options in the middle, which are puzzle pieces. Each of those puzzle pieces represents a programming concept. And on the right is the is the scripts area where you actually drag and drop these puzzle pieces. And notice at the top of the stage here, there's this green flag and this stop sign. Those mean go and stop respectively. And that's how we're going to run our program. And so what's nice about Scratch is that it very quickly lets us get up and running. In particular, there's these categories of puzzle pieces up here. I'm going to click on the control block, or no, rather, the events block. And I'm going to drag and drop this one anywhere I want. But I'm going to keep it nice and clean and just start it in the top left-hand corner. And notice this says when green flag clicked. And notice it's got a little nub to connect to other puzzle pieces. And I'm going to go to looks. And I'm going to choose this one. Say hello for 2 seconds. But notice these white boxes are editable. So I'm just going to say hello world. Let's just say for 1 second. And now watch the cat on the left as I click when the green flag. I've programmed. Now it's a simple program, but it's the Scratch equivalent to the Hello World program we just did a moment ago. So this isn't all that interesting. What might we like him to do instead? Well, let me, how about do something again and again? So how about the repeat block? And notice that I can disconnect these things. And even though it doesn't look like anything fits in there, it sort of magnetically wants to go in there. So I can let it snap into place. And now I can let this snap into place. And now, just because, I'm going to have him say hello world 10 times. Click the green flag. What's going on? Is this as expected? He's not pausing, but that's what I kind of hoped for, but I haven't been precise enough, right? Because if he's saying hello world for 1 second, but then immediately it's doing it again, and then 8 more times, I never told him to pause. So how do I prevent that? Well, let me go to looks, and show and hide isn't what I want. That's going to make the cat disappear. So how could I change this logically? And there's also, if I go to control, is it control? Oh, wait. Yeah, so it looks like it's too late. I can't fit that there. But again, magnetically, it will want to go there. So it will just grow to fit. So now I'm explicitly saying, wait 1 second, and let's see if this happens. So now it's giving him a chance to breathe, so to speak, whereby it's saying it for 1 second. But rather than immediately like close and open his mouth, so to speak, it's letting him close it for wait a second, then reopen it to say hello world. All right, so that's all fine and good, but it's not nearly as cute as it could be. I'm going to go under sounds here, and just so happens we have access to a sound block. And if I instead rip this out, and let me find the sound palette, and let me play the sound meow, and hit play. Uh-oh, what happened there? Let me try this. Now I'm puzzled. Let me play sound meow until done. Not very natural, but better. And let me steal this block. Slightly more realistic. Why did it not work the first time? Remember, let me undo this. Drag this in and hit play. I'm confused. Why is this not working? What could possibly explain this issue? Yeah, maybe the sound bites, it's only 1 second, so it's pretty brief. But conjecture why I'm not hearing it 10 times nonetheless. What's that?
Yeah, why is it repeating?
Maybe it starts to repeat before it even finishes.
Yeah. Yeah, at the risk of like oversimplifying, my Mac operates at 3.1 gigahertz, which means it does 3.1 billion things per second. And what I'm really telling it to do is only 10 things, but I'm not letting it wait until it finishes the song. So it's like this loop, and I certainly can't move my finger this fast, is doing this 10 times, and by the time it's done with all 10, the sound is still playing anyway, so it has the effect of really just playing it once, because it's happening that fast. The play sound until done is designed to block execution in that loop until the sound is done playing. And so even though it's going around pretty fast, and that's why it sounds a little unnatural, at least it's waiting until the sound is done to continue the next iteration of the loop. But waiting 1 second forces it to linger even longer, so it starts to sound even more natural still. So this is just sound. What about movement? And what about animation? How might you make games or in general interactivity? Well, let's again grab a control block. And let's just say forever this time, which is a different type of loop, if you will, or cycle. And let's go to motion, move 10 steps, and let's see what happens here. Oh, now I can, thankfully, this is designed for children, so he can never quite leave the stage fully, so we can drag him back. But the program's still running because it's in an infinite loop. And notice it's colored in yellow, which means that the program is indeed still running. What's going to happen if I change the 10 to 50, would you think? What would the visual effect be? Yeah, faster, right? Because this is cycling again and again, and every time the loop goes through, it moves 10 steps. I don't know what a step is, but it's probably a pixel or a dot on the screen. So let me change the 10 to 50. And if now on every iteration he's moving 50 steps, whew, it's pretty fast. Let's do 100. And now it's really fast. But let's add some let's add some logic now, whereby let's say sensing. Actually, let me grab control. So let me add an if, which is some conditional logic, and then sensing, because I know this is here. If touching edge. Let me change to a different direction. How about, OK, that was an accident, but cute. Let's stop that. Let's have him change 180 degrees. So let me, unfortunately, how do I reset the cat? He's in a funky place now. Well, we'll just let him go down instead. All right. So now he's bouncing off the screen. But this is as expected. I didn't quite intend for it to be diagonal, but so be it. And now we can add another little feature here. Let me go to sound, play sound meow. And now we can be a little more ridiculous here. This is now we're venturing into non-academic territory. Let me click the microphone. I'm going to allow my microphone to work. Let's see. Oh, delete that. Ouch! All right, so that's a waveform of my voice. I'm going to delete the part where it was just silent for a moment. Now let's go over here. Recording 1. I didn't give it a clever name. Ouch! 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 Right. Ouch! Ouch! So you laugh, but this is what programming is fun for initially. Ouch! All right. Ouch! All right, it gets very annoying very quickly. So let's ramp things up a little bit. I have some prefabbed examples here to demonstrate a few points. For instance, this one here, still a cat, still involving sound, but this one works as follows. Whoops, whoops, stop. See inside will show me the program. So this one behaves like this. I'm kind of spoiled. But does someone want to propose how this program works? Read code for the first time, perhaps. Yeah. Yeah, so if you pet this cat with the cursor, so it's a nice way of combining now a forever loop, so a looping construct, but not just an if, but an if-else. So there's two forks in this road, not just one. Let's try another example here where, let's do this one to show the precursor of this. This one, by contrast, does nothing at first until you do what? Until, so this is kind of the opposite, where you do want to pet the cat. All right, let's take things up a notch with, say, counting, sheep, which gives us a new capability altogether. Now, even though we haven't seen these blocks before, what does this program apparently do? Yeah, so this is kind of a play on words. So instead of you counting sheep, the sheep does the counting. But it introduces a new type of puzzle piece. This orange thing is what we'd call a variable. So like in algebra, you have x and y and z, and they store values like numbers. In this case, too, I'm declaring a variable, but it's more interestingly named than x, y, z. And indeed, in programming, it's common to name your variables more in a more descriptive way, like counter, setting it equal to 0 and then increasing it by 1 so that all this sheep does to infinity is count. really, really high. Though there's actually, you can see a bug pretty fast. Let me remove the weight. So now he's counting faster. Let me increase the counter even faster. Let's see if I can really break this. Let's see how high the sheep can count. Oh, this is a really big number. Come on, break. The sheep is not cooperating. My number's bigger than that, I think. I can't quite tell what's going on here. All right, I'm trying to simulate a fundamental limitation of computing, and I'm failing. Okay, computers can count really high is the takeaway of this example. At some point, per our discussion yesterday of how many bits are typically used to store data, it turns out that computers, and I'm not quite sure what's happening here. I think Scratch is simplifying this for us and only showing us part of the number. Computers typically only use 32 bits, maybe 64 bits to represent numbers, which is to say that they can only count so high. And what I was hoping would happen here is that the sheep would actually start misbehaving and start counting negative numbers or some other funky behavior. It seems not to be doing that, so it's a little resilient to this. But at the end of the day, this is a fundamental limit of most computer programs. If you only have 32 bits or 64 bits, which is, of course, finite, you only have a finite number of numbers you can represent. That might be a really big number, but it's still finite. And so there have been some very real-world examples of this being a problem whereby counters overflow, so to speak. You get to 4 billion, and then suddenly the counter goes back to 0. And frankly, even if you're not quite the technophile, you might recall that 16 years ago, we humans made exactly this mistake on an even larger scale with a much simpler problem, which was what? Yeah, Y2K. Thankfully, thanks to languages like COBOL and Fortran, enough of the world was fixed before the apocalypse happened in the year 2000. But what was the essence of the problem back then, which was a programming problem? Exactly, and why would that have been? That's true, but why? Why? That is true, but that was a side effect of a design decision in software. Grace? Yeah, exactly. They use 2 digits for the year because most computer software was invented in the 60s or later, and surely no one thought, especially in the government, that we'd still be running the same software 30 plus years later. But of course, as 2000 approached, we were still running some especially old systems. We're getting closer and closer to the year not rolling from 1999 to 2000, but from 1999 to 1000. Because you're only looking at those last 2 digits. So a lot of software had to be written in languages beyond even these because people had to go back and fix this. Now, it was plenty efficient, and you saved memory by only using 2 digits. But nowadays, this would certainly be an asinine decision in software because you all too easily start to bump up against these barriers. We're already running into an issue whereby historically clocks in computers are stored as the number of seconds from January 1st, 1970, just because, an arbitrary sort of moment in time, the epoch, so to speak, in computing. This is not great because you can only count so high with numbers that are of finite bits, and so even clocks are at risk of rolling over for similar reasons as well. It's sort of Y2K in a different way. Was there a hand a moment ago? Avi? Either they don't, and it's just not supported, or you have to use libraries that essentially use multiple numbers to represent one number. So maybe the first variable would represent the first digits in a number, and the second number would represent the other digits in a number, and you have to somehow do the appropriate math to combine those values somehow. But they would still use special software typically. So most modern computers nowadays are 64 bits, which means you can count up much higher. Specifically, you can count up to 2 to the 64, which is a number that big. If you need bigger numbers still, which programs certainly support, for instance, here's this calculator I'm using. It clearly can count even higher than that. That's because they're using multi-byte precision arithmetic, which means you use multiple bytes, not just 4 or 8. You use even more than that. But it's not built into the CPU. It has to be done in software. All right, so let's take a look at another couple of examples of what you can do with this. How about this guy, which is interesting because it uses yet another feature of a typical programming language. Here's what he does. And that's enough to get annoying. If I hit the space bar, program is still running, but he is muted. Why? Well, notice a couple of features of this program. One, this program actually has two scripts, so to speak. It is multi-threaded, if you will. A program is multi-threaded if it can do multiple things at a time in parallel. The fact that these two scripts are physically separated captures that idea, and there's an interrelationship between the two of them. In particular, what does the script on the right do in layman's terms? What does the script on the right seem to do? Anyone? Sets the baseline. OK, but what does that mean? Be more specific. The one on the right, though. You're right. Yeah.
Just like sets heat just says high for 3 seconds.
Under what circumstances?
At the start.
At the start, and in particular, there's a fork in the road there, so to speak. It's a one-way fork, so there's a decision point. It only says high, high, high if what is the case? If muted is 0. So I'm taking some liberties here, using 0 to represent false, or no, or off, and 1 I'm arbitrarily going to equate with true, or on, or such. And so when I say if muted equals 0, that means if muted is false. So if it's not muted is the corresponding logic, then play the sound and think high, 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 and then wait a few seconds and then do it again and again and again. On the left-hand side, how would you describe the functionality of that script? Exactly. If I press the space bar, for which it's listening constantly in that forever loop, change the value of muted from 0 to 1, else change it from 1 to 0. So it's a way of flipping the state of that variable. So just by convention, there's nothing enforcing this. I could use the numbers 2 and 3 or 9 and 10 or whatever. I'm using 0 and 1 by convention. It seems to be changing or toggling, if you will, the 0 to a 1 or 1 to a 0 based on whether the space bar is pressed, which means if I hit it again, the C line keeps talking. Now he's off. Now he's on. And you could liken this to most any piece of hardware. Like on your Android phone or iPhone, if you hit mute or pause, really there's probably just some kind of loop waiting and waiting. Hey, is he hitting pause? Is he hitting pause? Is he hitting pause? If so, pause the music. Or by contrast, and we can see this with one final example, software is often not sitting in a loop like this, which is generally not best practice because in many languages it will actually slow the computer down if you're just constantly doing this. Instead, it can be event-based, whereby you tell the computer in advance, hey, when the user hits the spacebar, let me know. And you leave it to the operating system or some other piece of software to let you know that, at which point you do something. And in particular, we can see it with this example here. Here are two puppets that work as follows. This guy, so just to be clear, we now have two sprites. So the blue guy is selected in the bottom left-hand corner here. The blue guy's purpose in life is to say polo when he receives something called an event, per my mention of event-based programming. The orange guy apparently does what when I hit the spacebar? He says Marco, but he also broadcasts an event. So the blue guy has registered himself as a listener for this event. The orange guy is responsible for broadcasting the event, and it's not quite a verbal broadcast. It's sort of a software thing. You're just visually, coincidentally, seeing him also say Marco. But that's not what the blue guy is listening for. The blue guy is listening for this thing called an event. And the result here is that nothing happens at first, but the program is running. But how do I make this program do something interesting? Hit the spacebar. The orange guy hears the spacebar. He says Marco. The blue guy receives that event, and he says Polo in succession. And so this is one way of having two sprites, in this case, or really two threads, more generally speaking, intercommunicate by way of what's called event-based programming. And it's a different paradigm from just sitting there in a loop forever, listening for something to happen. Now, we can be much more sophisticated than this. We can have multiple threads interacting in this way. This is an example of two sprites, both with forever blocks. But the cat clearly has an advantage here, because it turns out Scratch has a block that says point in the direction of another sprite. And so eventually, he will ever so closely catch up to the bird eventually. And you can see how that's implemented in the source code there. But then you can go even further. And in fact, one of our students implemented this one. Lest you be underwhelmed by these examples, one of our students re-implemented this game, which you might remember from yesteryear. And if I full screen this and click go, this is Blake Walsh, who's gone on to become one of our teaching fellows. So beyond getting distracted by the 80s here, let's consider how this program's probably working. I'm hitting my arrow keys right now. That's the only form of control I have. So how is Blake noticing that I'm hitting the left key, or the right key, or the down key, or the up key? What kind of logic does he probably have? Listener. Well, listeners, potentially, yes, potentially. Or a loop. So one of those two models, right? There's either a forever loop saying, hey, is the user hitting the left key? If so, do something, move. Else, don't do anything. And what's going to happen here, we've not seen this, but Scratch has a block that says is if touching. And actually, we did see this. We just saw that block in use a moment ago. When the cat caught up to the bird, it was touching the bird. That's what triggered the sound to play. And so what's kind of nice is once you have a bit of understanding of programming, you can look at something even as relatively complicated as this and infer how it's probably implemented. For instance, these cars, those three cars on the very bottom track. How is that working? Well, there's probably a forever loop. And every time the loop happens, there's like move 10 or move 50, whatever it is, and they're all moving to the left. And then there's probably an if condition that says, once you're off the screen, secretly go back to the other side. So those three cars, I'm guessing, we could check the code, are probably the same three cars. They're just sort of magically being reused by repositioning them there. And that's happening of all the cars. And why are they operating at different speeds? Why are they not all the same? Maybe there's different blocks, different loops for each of those cars, and that's why they're moving at different speeds. And then, you know, to be honest, as sort of complex as the game might seem at first glance, there's not much more to explain there, right? Like we've talked about sprites touching others. That's how you detect a car. Or if you hit the lily pad. If you're unfamiliar with what the heck this thing even is, the point of this game, if I can demonstrate this reliably, and this might be a bug. I don't think this is supposed to be stuck on the... I never caught this on Blake. I never just sat here talking about it. OK. Here we go. Now I'm on this log. OK, here. OK. I think it's very underwhelming. I don't think anything actually happens as you keep... Oh, maybe if we get all 7 of the lily pads covered there. Anyhow, there's really not much to this game. It looks complex. So how in the world do you go about building something like this? Well, I'm guessing when Blake set out to do this, he certainly didn't try to build the whole thing all at once. For instance, if you were to build this game, knowing only what you know right now, where do you even begin? What would be your first step if you were making a to-do list for building Frogger? Set up the boundaries. So maybe do the aesthetics first, like make some kind of graphic in Photoshop just to give you the road, because the road isn't changing. Like the screen is physically moving right now in the breeze, but the road isn't moving. The purple stuff, the black stuff, the green stuff are all fixed. So those are just images. What comes next? Yeah. OK, so the basic story, and what's one of the first pieces of the story you could bite off? Like what might version 1 of your game do and only do? All right, maybe just the cars, right? And frankly, I wouldn't try all the cars. I'm going to pick one of these yellow and red cars. I'm going to figure out how to just initially put it over there on the right, and then let me just make it move. And it wouldn't take you very long, right? I move that cat from the middle of the screen to the right of the screen pretty fast with just a couple of blocks, a couple of puzzle pieces. And then I might have to think about, all right, when he's off the screen, now I need to put him back. But you could imagine after 5 minutes, 20 minutes, an hour, like figuring out how to move this one car, then you could probably duplicate or somehow clone that block and make sure he's spaced a little farther away from the other cars and do it twice. then do it 3 times, and then move on to like the purple cars here and do the same thing again. Then move on to the white and green, and then the trucks. It's all really the same kind of thing. Now, in a language like Scratch, you might end up duplicating a whole bunch of code using the same things again and again. In more modern programming languages, there's a way to reuse code. So you only implement one piece of code that moves a car, and you somehow parameterize it or configure it to be configurable to use yellow car, purple car, blue car, big truck, and maybe the speed too. So maybe the black box that is your movement code accepts as input the color of the car and maybe the speed of the car and maybe the direction too. But you can reuse that code, and that would be good practice. And then after that, what about the frog? Well, we could implement it on a separate day. So that was my Saturday homework. On Sunday, I might implement the frog. And using events or for loops, I just have to somehow respond to up, down, left, or right. And maybe he can go absolutely anywhere. There is no notion of water initially because I just want the thing to work. Then I go and implement the black water here, which I didn't fall into it, but I'm pretty sure I'm not allowed to walk onto that. Let's see. So this is probably another feature. Oh, it's not even black. It's purple on my screen. It's black on the projector here. So actually looks like water, and so forth. And so this would be generally known as like hierarchical decomposition or functional decomposition. Like, how can you go about taking a big problem and breaking it up into smaller, much more palatable tasks, maybe tasks that we could distribute. So Nicholas does one thing and Avi does another and so forth, so that collectively we bring together the collective solution to this problem. And so that's pretty representative. Here, one other, the very first program I wrote in Scratch, like in grad school years ago, was this, which has been modernized by one of our TFs now to be more green. I implemented what's called Oscar time, whereby trash falls from the sky, and you're supposed to drag it into the trash, at which point Oscar appears. But as of 2015, we are green now, so there's now been added a recycling bin and a compost bin. And this was meant to help subliminally teach the undergrads. Oh, that should be compostable. That is. Subliminally teach people what is compostable. Anyhow, I can say from personal experience, part of the process of coding is also debugging. Oh, that's fault. There is nothing, I hate this song now. Like hours and hours of playing with this game trying to get it right. Never again. Anyhow. But something like that, what are the building blocks? Well, I don't quite remember because it was so many years ago now, but I think I started with just the stage. Like I got the aesthetics right in the lamppost and the trash can just because I wanted to have like a mental model for the game. Then I think I just had one piece of trash fall, and it just fell from the same place every time. Then I added the feature for dragging and dropping so that I could lift it and then it would fall again. And that wasn't all that interesting. And then I added the feature to detect if it's touching the trash can, at which point I hide the trash. Then I didn't want the trash always falling from the same spot, so I added a bit of randomness. And indeed, Scratch and computer programs more generally let you have randomness, pseudo-randomness technically, that allows you to move the position either here, 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 based on a range of values that you give. And so there too, I sort of took the equivalent of baby steps until the net effect, hopefully, at least I thought, was very impressive. But it was the result of very small bite-sized tasks. And this is a general principle of software design, modularizing things such that you make very small progressive steps so that one, you feel emotionally like you're making some progress. Two, if you made mistakes, bugs, so to speak, they're within very narrowly defined spaces, very few lines of code. And three, so that you can work with others, each of you contributing little pieces of code. And this would be generally best practice. So why don't we go ahead and do this. Let me pause from speaking and propose a challenge or so as follows. Maybe a left half, right half kind of challenge. Would anyone on this side of the room like to propose a very simple program using a cat and maybe nothing more that we would like this half of the room to implement? What would you have the other half of the room implement using just one cat as an ingredient? What do you want them to do? So while they're thinking of something, what would you all like to challenge the other half of the room in doing?
Maybe once a cat hits an edge, it duplicates.
Duplicates.
Once that cat, once out of the two
Is this possible? I like it. Let me. Is it with the clone broadcast? let me just, okay, I think this is possible, and I will give you a hint. Right half of the room, I think you'll need to use this puzzle piece, which we've not talked about, but does what it says. Create clone of yourself. And so just to be clear, we want something.
So just self-duplicating it. So anytime one of the duplicates hits it, they duplicate as well.
OK, so I'll elaborate. Like the cat should be moving around. Every time he hits the edge, he should maybe double. So one becomes two, and maybe add some randomness so that both copies don't go in the same direction where we won't see them. There's got to be some randomness to the angle. All right, so you should have spoken first. So what would you all now like to challenge the other half of the room to do?
Well, I'll let Dropbox have him dedupe.
OK, so how would this work exactly?
I don't know, maybe he has to shrink or.
OK, we can go with that. So how about every time he bounces off the wall, he shrinks in size, starting large and going small. And feel free to call me over, but the lesson here is, one, to just give you a sense of the logical flow, see how many different answers we get, and it'll be a nice transition, I think, ultimately into lunch. Avi. You're welcome to collaborate with your partner next to you, but let's get as many working implementations as possible. But you're welcome to lean on someone else for some help. And the goal here will be, I would encourage you first, flip through all of the various puzzle pieces that are accessible. Just wrap your mind around what the ingredients are, and then think about how you might implement. And if you would like to remember some of the examples we just did, especially involving motion, if you go to today's slides, after the Scratch URL is this one here. This Studio's URL will lead you to all of the examples that we just flipped through, if you want to see those as well. All right, despite my constant refreshing, we have just these 5, but that's OK. Feel free to still add if you'd like. So let's take a look at this one here. And see, OK, so Scratch seems to start quite small. He seems to be just a fleck on the stage over there. I'm going to go ahead and blindly do this. Is this as expected? Oh, wow, that's an unexpected feature. And now he's getting smaller, but he's so large, not very quickly. This is the one called left side smaller. Wait, when in doubt, reload. All right, so let's see how this was working. So we have just one script here. And when space key pressed, change size by 10. I made the mistake of holding it down in perpetuity. So forever, repeat 10 times, move 50 steps. OK, so if it's OK, let's critique or react to some of these blocks of code. Repeat 10 times, move 50 steps. I do think there's an opportunity for improvement here. What could we do to express this equivalently with less code, so to speak? Yeah, I would just replace this potentially with one move 500 steps block, just because it cleans it up. And this would be a general principle. If you can express as clearly but more succinctly some operation with less code, you should. If on edge bounce, so that's what's getting the cat bouncing back and forth. It looks like this middle if condition, if touching edge then nothing, that's probably just left over from a previous idea. So that could be removed altogether. And if touching edge, then play drum for drum number 12 for 0.25 beats. And then change size by -5. So that -5 is what keeps making the cat smaller and smaller unless you're holding down the space bar. So let's play it once more. That's a neat effect in the end. So that's what the drum sounds like. And if I hold the space, it gets bigger, then gets smaller, 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 until I do this again. Really cute variant, adding the space bar there. All right, so let's take a look at another one here. We have a nice stage. So someone took to heart my suggestion you always start with the stage. Already, we have a nice backdrop here. Let's hit play. OK, so let's see. When I start as a clone, move 5. Did I hit the? Oh, there we go. Nice. Nice. Oh, my God. That's kind of mesmerizing.
That's cool.
And what effect do you see happening besides more cats? This is adorable. I think we're going to have to use this example in the fall. Something's happening, though. Changing of direction. Yeah, it seems to my eyes here like it's all kind of getting slower, like it's getting a little more stuttery. Yeah, and honestly, I think we must have already hit the limit, because if we are doubling every time, think how quickly, after doubling 32 times, how many cats would there be? Start with 1 cat, double it in 32 times. 4 billion, right? There's only 4 answers mathematically the past 2 days. So 4 billion cats. I'm pretty sure I don't see 4 billion cats, because it would probably be just a bigger mass even. So there probably is some limit, but even that limit is pushing the limits of Scratch. But very well done in terms of the spec, and a nice pretty background. Let's look at a third here. Go back here. Balloon cat. All right, hit play on this one. Let's see inside. Hit play here. When space keep. Oh, very cute. So he kind of pops when he gets smaller and smaller. And then he does that. Nice. Very nice. All right, let's go here. This one's just in. Cat dot dot dot. See inside. He seems to be getting progressively smaller. And there does seem to be a lower bound on how small they let Scratch get. Not in this one. Not in this one. Cute. All right, very nice. And let's see, 2 more. Scratch shrink. All right, starts a little big. Nice. There's more randomness, it seems, to the angles this time. These are really cute. All right, and if I hit the space bar, he gets 200% again. But there, too, you can see the limits of too much happening at once. When I hold the space bar, when he's bouncing, I can't quite induce it again. And even the sound is kind of struggling to keep up. Very nice. And last but not least, runaway sprite. Oh, another clone. I love it. Oh, it's mesmerizing. I love it. Oh, now you... Ew. That's really cool. There's something very Simpsons-like about it, too, somehow. Oh, well, congratulations to both sides, and thank you for the challenges. Those were terrific. Why don't we go ahead and we'll take a break, and at 1:30 we'll resume, taking a closer look at libraries, at frameworks, and technologies more generally.